In the chapter 5, we'll be looking at a study of shade and shadow. We'll be dealing with this in 4 parts. In the first part, we'll be studying sun path diagrams, how light interacts with surfaces, where we'll study about the illuminated surfaces, shade and shadows. Third, we'll study about the dynamics of shadow. So this completes your part A. For part B, we'll study orthographic projections of shadows of point and line in different conditions. In part C, we'll be studying the surfaces and solids, prisms and pyramids, how light and shadow interacts with these. And part D will be covering psicography of perspectives.
Let us start with the sun path diagram. The sun path diagram shows us the position of the sun all throughout the day as well as all throughout the year. This is an indicative diagram which shows us the movement of the sun across the sky. So this has 3 parts based on which the position of the sun is identified. Azimuth or angular distance, bearing or angular direction, and altitude or angular height. So bearing and azimuth are measured in the horizontal plane, whereas altitude is measured in the vertical plane. All these are angular in nature. So this circle is indicative of the direction where the north, east, west and south are. In this case we have considered it on the southern direction, exactly above the south. So we can see a shadow here on the north. So from here, let us now look at the illumination, shade and shadow. For this we have considered the sun to be at a 45-degree angle or altitude. So the sun is coming from our left top corner, as we see, and the shadow is formed on the opposite side. So the surface that receives this shadow is illuminated or illuminated surface. In this case we have 2 surfaces visible. The surface that receives the reflected light and not the direct light is in shade, is called as a shaded surface. And the line that separates the illuminated surface and shaded surface is called a shade line, which we can see this and this are your shaded line because they are separating your illuminated surfaces and the shade surfaces. Then we have the shadow being casted from these edges of the illuminated surface. The shadow is casted on the horizontal plane. So this is the shadow. So now if we look at this, the shadow lines are parallel in nature because all light rays are considered as parallel. The sun is so far away that all light rays are virtually considered as parallel. And the imaginary line that is the outline of the shadow is called as the shadow line. Next, let us look at the dynamics of the shadow. In this, we'll be looking at how the shadow varies based on its position relative to the vertical plane as well as the horizontal plane. So we have 4 objects here which are kept at increasing distance basically from the vertical plane. So the object that is furthest away from the vertical plane, its shadow is being casted completely on the horizontal plane. So we see a longer shadow here. Notice that in all these 4 objects, the light source and position is the same. So the light, we are considering it as a constant, and only the position of the object is varying here. So these four objects, the shadow is purely casted on the horizontal plane is the longest. The one which is closer to the vertical plane, number 2, has most shadow on the ground, whereas part of it is getting onto the vertical plane. Also notice how the shadow moves up at a right angle and goes on to the receiving vertical surface. So the same happens with 3 where it is almost half a shadow in both horizontal and vertical planes. And then the fourth one is the nearest to the vertical plane, so the entire shadow is casted on the vertical plane. Almost entire shadow is casted on the vertical plane and is relative to the object. It looks as if it's a true object. Next, let us look at the condition where the object is moved up in the z-axis. So the reference lines, you can note that all the shadows are parallel. All the objects are in one straight line. You can see that the shadow of the object that is on the horizontal plane starts right from the base of the object, whereas as the object moves higher and higher, the shadow starts further away from the object. So now let us look at the combination of both cases in one. Right? So the first object is on the ground, so we see the complete shadow starting from the base. Second is slightly higher and further back, so we see it accordingly the shadows moving away as well as onto the vertical plane. The third one, since it is moving up the object line, the shadow has also moved back. In the fourth case, complete shadow is on the vertical plane. Also, it looks almost as if it's a true object in itself.